So today we discuss change of phase means state and latent heat. Okay, the calorimetry chapter part B. So discuss change of phase, change of phase uh, in states and latent heat. Huh? Okay, so first draw some a diagram. Okay, so we consider that is a solid body, solid. Another state is a liquid. Another state is a gas. Three states. Okay, so now change of states. Okay, if heat is input in solid. Okay, if solid is heat absorbed. Solid is heat absorbed the Q, then solid changes to liquid, and this is called melting. Okay, so what is melting? When a solid takes heat and heat absorbed, the solid turn into liquid. Similarly, if liquid gets heat, some amount of Q heat, then liquid turn into a gas. Okay, and this is called vaporization. Similar, if gas release some heat, okay, gas release heat, then gas turn into liquid, and this is called a condensation. Similar, if liquid release a loss of heat, then liquid turn into solid, and this is called freezing. So loss heat Q, and it's called freezing. Okay, so very important is when some material, some object, when heated, some object or material is heated, then they skip the liquid part and directly gas. When skip that liquid part and transfer into gas when heat is absorbed. When heat absorbed. Okay, so these transfer solid to gas is skip the liquid states and is called sublimation. It's sublimation. Okay, called sublimation. Similar case when gas release some heat and turn into solid. Uh, it is something solid and directly they skip that liquid part. So this is called a solidification. Solidification. Okay. So I skip the definition. We all know that what is melting, what is vaporization, what is condensation, what is freezing, and what is sublimation and solidification. Okay. Now here we discuss the melting and freezing concept. Okay. So melting, what is skip that part, but write some definition. That's important. Okay. So what is a melting and what is freezing? There is a reverse process. When solid gets some heat or solid absorbs some heat, then solid turn into liquid. So solid change of state. Like a water is ice, and the solid state of water is ice, and now if ice gets some heat, and then ice turn into liquid, and this process is called melting. When liquid, when a glass bucket of water put in a freeze means the temperature is very small, so the liquid lost some heat. If lost some heat, the liquid turn into a ice, means the water turn into a solid. It's called a freezing. So here important, what is a melting? the changes state, what is the melting? Definition of melting. Melting is the changes from solid to liquid. Solid to liquid is called melting. Okay. When absorbing heat. Okay. Now another important point is called melting point. Okay. What is the melting point? If you know the melting, and that's important is the what is the melting point. That's important. What is melting point? Melting point is a constant temperature, a fixed temperature at a point or a temperature at a constant temperature. The constant temperature at which a solid changes to liquid. Solid changes to liquid. What is the constant temperature? Some take an example. Is water. Melting point of water is 0 degree centigrade. Melting point of water. Okay, that's a melting point. So another important thing is discuss here melting and freezing. If it's 0 degree ice, 0 degree centigrade ice. Okay, when some absorb heat, when some absorption of heat, of heat, then these ice convert into water, 0 degree centigrade of water. Similarly, but here you see that the temperature is fixed, but the heat is absorbed. Similarly, the another concept is the heat is released. Okay, liberation of heat or release the heat. Of heat. Then 0 degree water turn into 0 degree ice. Okay, so here the important factor you know that temperature is fixed, but state may be changed. So solid to liquid and liquid to solid, state change, but temperature fixed. Okay, 0 degree centigrade temperature, but state is changed, but heat also change. Very important. So if I draw a graph here, that curve of melting, melting curve, we see that melting curve, a graph actually. Okay, if we there is a temperature and here we that some also time. Okay, okay, x axis is the temperature. Here is time. You see that temperature means suppose zero. Oh, okay. So temperature is constant. Temperature is constant in ice actually. Some time 0, 5, 10, 15, 20, approx 25. Suppose let's say that if 0 to 20, okay, so 0 to 20, this time the 20 seconds, 0 to 20 seconds at that time, 0 to 20 seconds, this time, okay, that's not over the if I mark 0 to 20 seconds, this time. Okay. At 0 to 20 seconds, see that the temperature is constant, but fixed 0 degree centigrade. Now, but all ice means actually here the ice plus some water, some because some little amount, some time to time, some small amount of ice converted into water, some small amount of ice converted into water. At that point here, in 20 seconds or 20 minutes, here we see that all ice convert into water. Here is no water, but here no ice. In between, all ice, so time to time, all ice, some small amount of ice convert into water, then small amount of ice convert into water. Here we see that the all ice convert into water at that point. Then time increases, temperature also increases. Okay, the time increases, temperature also increases. But here is no ice, there is only water. 30, 40. Okay, there is all water. Suppose that is 10 degree, 20 degree, or 30 degree centigrade. Okay, but at that point here, heat is absorbed. Q is absorbed. Okay, that's the heating curve of ice at 0 degree. It's called a heating curve of ice at 0 degree. This graph is called heating curve of ice at 0 degree centigrade. Okay, so another important factor, change in volume on melting. Okay, so another important factor is hmm, uh, change in volume, change in volume on melting. Okay, so yeah, important things like a lead, wax, etc. Most of substance expand on melting. Some substances, some substances expand on melting. Why? That's important thing. We know the solid, these are called a solid, that is a consider that a 6 molecule, and this is the intermolecular space. We know that in case of solid, the intermolecular space is very less. Okay, when some heat is absorbed, then the intermolecular space is increases. We know that the liquid has more intermolecular space than solid. If intermolecular space is increases, some like the previously here, now after liquid is here, and this transfer here, here, and we see that there is some expansion. There is some expansion. Black color represents the solid, and green color represents the liquid. So if heat is absorbed, so we see that some body intermolecular space is increasing and the intermolecular force is less. If intermolecular force is less, so attraction is less. That's why there is some expansion. For example, the 1 gram of solid wax volume is 1.61. 1 gram of wax, uh, if they are in solid, right? So volume is 1.16 per centimeter cube, and it is a liquid. So 161 actually 161 in case same the wax is liquid, that is 1.166. Then slightly change means consider there is minus 0.006 centimeter. 1 gram is expansion. That is, I think, that increases. But in some cases of water, there is like a 1 gram of ice in case of water. So the exception is 1 gram of water. The volume of 1 gram of water is 1 point in ice. Volume of 1 gram of water is 1 centimeter cube. Similarly, the 1 gram of ice volume is 1.091 centimeter cube. So solid has more volume than liquid. There is some exception. Okay, there is more volume than liquid. Similar case, we know that ice has less denser than water. That's why ice is float in water. Okay, the ice has less denser than water. We know that. Okay, the effect of pressure on the melting point. Another important point things. Effect on pressure. Effect on pressure on the melting point. On the melting point. What happens when pressure is increasing or decreasing? If pressure is increasing, some point melting point substance pressure increase or decrease increasing pressure. Okay, so melting point decrease, the pressure is increased. So pressure and melting point, they are inversely proportional. If pressure increasing, so melting point is decreases. Okay, so they are inversely proportional. If pressure increasing, so melting point is decreasing, and pressure is decreasing, the melting point is increasing. So take an example: melting point of ice. So example here, so melting point of ice. Example is decreased by 0.0072 degrees, 0.0072 degrees centigrade by the increase of 1 atmospheric pressure, by the increasing of 1 atm. Okay. On the other hand, some melting points are other substance like a wax, lead, okay, which has the expand on melting and increase the increasing pressure. Okay. Next concept, the effect of pressure is another concept is impurities. That's very important. If impurities added in the substance, what happens at melting point? When impurities added, effect of impurities, effect of impurities on the melting point, on the melting point. MP stands for melting point. Okay. If some impurities is if some impurities is added. Okay. Some impurities added, the melting point is decreases. Okay. If some we do like example, if some impurities added, if impurity is added, then melting point is decreases. Take a beautiful example. When salt NaCl added to water, added to ice, added to ice. Okay, salt is impurities added to ice. So melting point is drastically decreased, like minus 22 degrees centigrade now. Okay, from 0 to minus 22 degrees centigrade, this drastically is decreasing. Okay, if I added a proper proportional, proper ratio of that salt and ice. Okay, so that is a very important beautiful thing. And if there is a melting point is decreases, there is a preparing for cool feeds. Okay, we get that when some vendor, ice vendor, okay, they carry some bucket or basket, thermocol basket, and in thermocol basket there is some Pepsi on some ice cream or cool fish. Okay, and these ice cream and cool fish are in there some ice here. Okay, in baskets there is some ice, and these ice mixed with number perfect proportion of salt here mixed with that ice, so that melting point of ice is drastically fall, and some ice cream and some Pepsi like a Pepsi and some cool piece and are present here, and then close that bucket, and that's very good. And after 1, 2, 3, 4, 5 an hour, 6 an hour. There's enough time. That's the ice and could also they are in solid states. Okay, there is also very cold. Okay, that's a public brain there. Okay, see that very beautiful things. Okay, there is a science behind the science is very important. Next point, vaporization and boiling. The melting is there are some factor. There is a two factor. Here is a summary that portion. We know that change of phase of state and latent heat. We know that block solid to melting, liquid, liquid to gas, and there's a solid to gas and gas to solid. Okay. So here is the important first is the melting. Okay, melting and freezing. They are inversely. If solid to liquid is melting and liquid to solid is freezing. So important is the melting point. Okay, and what is the melting point depending on factors some like pressure and the impurities added in the solid. Another important thing that the melting changes volume on melting. Some substance like wax, they expand, but exception is the water. Okay, there's a melting point curve at melting point curve on 0 degree centigrade. Okay, heating curve. And now we discuss the vaporization or boiling. That's important. Okay. Or boiling. So what is vaporization or boiling? You see that block diagram. Okay, some liquid when you heated some liquid, actually the heat is absorbed by the liquid. Then some liquid change of state. Okay, so liquid turn into the gases. Now, write the definition of that boiling or vaporization is very important. When the changes from liquid to gas, the changes from liquid to gas or vapor in the phase of absorption of heat uh, of heat at constant temperature is called vaporization. It's called vaporization. But at a particular temperature, very important fact is at particular temperature, a particular temperature, at which vaporization occur. Uh, occur is called boiling point. Called boiling point. Okay. So some like if I draw that some diagram here. Okay. Some 0 degree to 100 degree there's some liquid. Now is 100 degree centigrade of water is heated. Heat is absorbed. Heat is absorbed. Then that 100 degree centigrade of water turn into 100 degree centigrade of vapor or steam. When its heat is released, this 100 degree centigrade of vapor turns into 100 degree in liquid, and this is called a boiling. This is called a condensation. Condensation. That's two important things. And here you see that the 100 degree centigrade of water turn into 100 degree centigrade of steam or vapor. Similarly, the 100 degree centigrade of vapor turn into 100 degree centigrade of water. The important factor is sometimes heat is absorbed, sometimes heat is released. When heat is absorbed by the water and then water turned into vapor. This is called boiling. When some vapor we condense, heat is absorbed from the vapor, and then the vapor turns into liquid. Is at the same constant temperature 100 degrees centigrade. This is called condensation. Now, if I draw the heating curve of water, I here draw heating curve of water. We get that. Suppose uh, here is the time, similar that here is the temperature in degree centigrade. See that graph. As a graph. So sometimes 0, 5, 10, 15, 20, 25, 30, 35. Okay, and time is 0, 10, sorry, temperature 0 to 10 degree, 20 degree, 30 degree, 40 degree. Okay, to 100 degrees centigrade. Okay, so some water, 0. So 0 degree some liquid, some time, suppose taken some time here, at some time here, at that point, that is a liquid. There is a liquid, okay. But after crossing that at that point here is a 0 degree centigrade of sorry, there is a 100 degree centigrade of liquid or water. Now time is increasing here, that is a constant. At that point here is the boiling. Okay, but here we get a 100 degrees centigrade of water. After some time like this, here we get 100 degrees centigrade of steam. So this is called a boiling. Temperature fixed, time is increasing. Here say that the time is increasing, but temperature is fixed. And there is an important state also change, the liquid to gas. So this is called a heating curve of water. Now some factor affecting that boiling. Okay, some factors like that. Change effect of pressure on boiling. Effect of pressure on the boiling point. On the boiling point, not blood pressure, that is a boiling point. So important thing is boiling point. Okay, so boiling point of liquid is increasing with the increasing pressure. If pressure increasing, so boiling point also increasing. So pressure is really proportional to boiling point. Okay. Here, take an example that suppose we get a 760 millimeter of pressure, 760 millimeter of Hg pressure. So boiling point of water is 100 degrees centigrade. No, okay. So now we get in case of pressure cooker. So in case of pressure cooker, we seal that part. Okay. And here the pressure is also increasing. Okay. So here this pressure is increasing in pressure cooker. The pressure is really increasing, hugely increasing. So that is almost 1.75 times the atmospheric pressure. The inside the pressure cooker, the pressure is 1.75 that outside the pressure. So approximately outside 100 degree centigrade at boiling point, here inside the pressure cooker we almost get a 120 to 125, 120 to 125 degree centigrade. centigrade inside. Okay, so that is less uh, time taken for cooking. That's a pressure cooker is very efficient. Okay, so or in case of high altitude, high hills or high mountain, atmospheric pressure is very low. So there's a lower than the temperature needed to boil. Okay, at high altitude mountain, here it is a mountain, its pressure is low. Pressure is low, so boiling point also low. Since a higher mountain, here the boiling point I think that's 80 to 90 degrees. That is the boiling point. Okay, in hill areas. Okay, high hill areas. And another is called impurities. So the main important things is that is pressure directly proportional to boiling point. Another effect is impurities. So if you have some impurities added, okay, um, so they are also directly proportional. So impurities added, so that boiling point also increases. So impurities proportional to boiling point. Okay. So if I salt added in the cooking, when you see that when some the oven, when some salt is added, okay, and salt is added, then that is the also the boiling point also the increasing. Okay, salt added to water or uh, some cooking or frying or any curries or make some vegetables. So when you some see that some chef added some salt, or we actually we making when we making the food we some added some salt. Okay, that salt is added, so get boiling point is also increasing. Mm. Temperature is higher than 1000 degrees, higher than 100 degrees centigrade. So temperatures are also increasing. So impurity is added, so temperature also more than 100 degrees centigrade. So that is cooking is very faster, provide the sufficient heat to contain before the boiling. Okay, easier and faster process, cooking very fast. That's why salt is added. Okay, the salt is added. Another important thing, when salt added, so cooking is very fast process. Okay, so today in the class here, next class we discuss latent heat and specific latent heat. Thank you.